Here at Google, data centers are very, very important to us. They are how we deliver all of our web services to all of our users. And a data center can mean a variety of things. It can mean a small closet filled with a couple of machines, all the way to very large warehouse scale buildings that are optimized for power use and IT computing and filled with thousands of servers. And at Google, we've spent a lot of time innovating the way in which we design and build these facilities to minimize the amount of energy and water and other resources that these computing facilities use. In terms of the results of all of the work that we've been doing over many, many years, now we use half the energy of a typical data center. To put things into perspective, the entire ICT sector, that includes mobile phones, computers, monitors, cell phone towers, is roughly about 2% of global greenhouse gas emissions. Of that 2%, the data center portion is responsible for about 15%. There's design choices that you can make for energy efficiency that improve the performance of your data center. And these things are just best practices, and adhering well to best practices, that's how you can actually make the most improvements in terms of energy use. The results of these types of activities return Google millions of dollars in energy savings, so the results are significant. We've invited several members of our data center team here to explain some of these best practices to all of you.
The first step in managing the efficiency of your data center is to make sure you have the instrumentation in place to measure the PUE, or power usage effectiveness. PUE is the ratio of total facility energy to IT equipment energy within your data center. It's a measure of how effectively you deliver power and cooling to the IT equipment. In 2006, the typical PUE of an enterprise data center was 2.0, which means for every 1 watt of IT energy consumed, 1 watt of overhead was consumed by the facility to deliver the power and cooling.
Reducing the overhead is really what you want. You want PUE to get to as close to 1.0 as possible.
Over the last 12 months, our TTM PUE was 1.16. We've continuously measured that, and it's gone down in nearly every quarter since we began reporting it back in 2008. Last quarter, the lowest data center was 1.09. Ideally, you should measure it as fast as you can, as often as you can, every second or so. And the more often you can measure it, the more meaningful the results will be. It's important you measure PUE over the course of a year, annually or quarterly, to get meaningful results. If you just take snapshots in time, the information won't be realistic, and it won't really be an actual measure of how well your data center is operating. One way to make it easier to manage is to incorporate the PUE measurements into your billing management system. And we do this at all of our sites at Google. Without having easy access to this data, we wouldn't be able to operate our data centers as efficiently as we do.
Once you have the ability to measure and manage your PUE, the first step in terms of reducing your data center energy load is to focus on the management of the airflow. The most important thing here is to eliminate the mixing of the hot and the cold air. And there's no one right way to do this. Containment can be achieved through many different approaches. One thing that we found very useful at Google is CFD analysis to see where are your hot spots and how is your airflow going to actually be directed in your data center. By doing so, you can actually model the way in which airflow will go, and it helps you make very simple design choices to improve the airflow in your data center. For example, in one of our computing and networking rooms, we call them CNRs, we actually did some thermal modeling to see exactly what airflow was doing. Through that modeling, we realized that the intake to our cracks was too low, and that by simply piecing together some sheet metal, we could create extensions that would dramatically increase the airflow quality into the cracks. We also did a bunch of other retrofits.
Here in this corporate data center at Google, we've implemented meat locker curtains that are very inexpensive and easy to install. These are hung from the overhead structure, and they separate the cold aisle, which is actually hot, and the hot aisle, which is actually hotter. We are set now to enter the hot aisle containment door, and we incorporated the simple, inexpensive sheet metal doors to separate very tightly the cold aisle from the hot aisle. Now over here, we've got the hot air from the racks are coming up, going overhead up through the return air plenum, back to the crack units to give you a nice high temperature differential across your crack units. A very important step is to seal the rack space where you don't quite have all of your equipment populated. And it's very easy to do with these blanking panels. It's almost like weatherizing your house to make sure that you've got a nice, tight environment.
All told, we spent about $25,000 in parts, and those $25,000 saved us over $65,000 in energy costs yearly. Once you manage your airflow properly, the next step in data center efficiency is to increase the temperature of your cold aisle. And it's long been believed by many data center operators that the data center has to be cold to keep all the equipment at a temperature that it will run safely at. And in fact, that's just false. So if you look at recommended guidelines from ASHRAE, they recommend you running all the way up to 80 degrees Fahrenheit. And at Google, that's exactly what we do. We've got a small corporate data center here. It's about 200 kilowatts of load. Simply raising the temperature from 72 degrees to 80 degrees saves us thousands of dollars in energy costs every single year. What's nice about that is it also allows our employees to come to work in shorts. Whenever possible, we recommend people to free cool. Free cool means utilizing ambient temperatures outside of your data center to be able to provide cooling without operating very heavy energy consuming equipment like chillers.
We use free cooling on all of our data centers. And you can see this in our publicly reported PUE data, where the PUE values go up in the summertime and down in the wintertime. And this is just a reality of running our operations with free cooling. And it yields tremendous efficiency gains. In Europe, we have 2 data centers that have no chillers whatsoever. We're able to take advantage of the local constraints and conditions. In Belgium, we use evaporative towers without any chillers, given the ambient conditions. In Finland, we use seawater cooling. Seawater from the Bay of Finland cools the servers, and then we temper the water returning to the Bay of Finland so there's no temperature gradients returning to the bay. Evaporative cooling uses water on site, but what we found through our studies is that by the use of evaporative cooling in a very efficient fashion, we save water on the whole. So for every gallon of water we use in the evaporative cooling plants, we eliminate the use of 2 gallons of water on the energy production side. So this translates into hundreds of millions of gallons per year in water savings. There's no one right way to deliver free cooling. The important point is that you should examine these opportunities and take advantage of them to eliminate or reduce substantially the mechanical cooling.
In a data center, you pull power in from the electrical grid and you convert it down to the voltages that are needed for all the components in the data center. And there's a lot of conversion stages in there. By minimizing those conversion stages, you can save money and save energy. Also, by making each conversion stage more efficient, you can save energy as well. Traditionally, one of the big losses is the UPS system, the uninterruptible power supply. Typically, there's a giant room of batteries. Batteries are DC voltage, and the power coming in to charge those batteries is AC, and so you need to convert the AC down to DC with a rectifier in order to charge the batteries. And then when the batteries are needed in a power event, you need to convert that back to AC with an inverter, and then the AC needs to be converted back down to DC for all the components in the data center. So you've got 3 conversion stages in there that are not necessary. What Google has done is put a battery on board the tray, so you're eliminating those 3 conversion steps. You just have DC right into the server components. In a typical server configuration, you have a server with an AC-DC power supply attached to it. By making sure that AC-DC power supply is efficient, you can save a lot of energy. Things like Energy Star labels will point you to power supplies that are 90+% efficient. Google is able to save over $30 per year per server by implementing all of these features.
There really are very simple, effective approaches that all of us can implement to reduce the data center energy use. And most of them are cost effective within 12 months of operation. So a lot of efficiency best practices should be adopted by just about everyone. They're applicable to small data centers or large data centers. It's simply following the 5 steps that we go through here to make sure that you're able to reduce your energy use.